The overall goal of this procedure is to detect amygdala activity during learning using magnetoencephalography, or MEG. This is accomplished by first designing an implicit fear learning task that activates the amygdala. The second step is to record brain activity during the task using MEG. Next, identify the surfaces of the cortex and the amygdala using high-resolution anatomical MRI scans. The final step is to use the surfaces of the cortex and amygdala to model the neural sources of the MEG signal. Ultimately, source imaging models can be used to show neural activation in the amygdala during learning without awareness.
So the main advantage of this technique over existing methods like fMRI is that MEG signals are recorded in real time and they can be used to study neural processes that are rapid or transient.
Though this method can be used to study amygdala function, it can also be used to study the function of other subcortical regions as well.
Begin by connecting the stimulus presentation computer to the MEG acquisition system using a standard DB25 multi-connector ribbon cable. Next, connect the stimulus presentation computer to the Scilab standalone monitor, or SAM, using the 8-bit to 2-bit isolation adapter and the synchronization cable. The transistor-to-transistor logic pulses used to mark the stimulus presentations can cause artifacts in the MEG data if they are sent to the SAM. To avoid these artifacts, mark the onset of the stimuli using